Hey guys, welcome to Easy Civil Engineering. My name is Shubham and I welcome you into my engineering world. Our today's topic of this particular playlist, specifically of civil engineering, is detail of total station. We know that total station is one type of measuring instrument, and about knowing about total station is extremely important for every civil engineer. That's why I selected this topic as one to make a video on, so that everybody can learn, and me also. So what are the key objectives of this video? That first one, what is total station, what type of data you can compute using total station, you can collect using total station, what are its different parts, and which all type of operations you can perform, and lastly but not least, what are the advantages of that. So we will fulfill all these objectives, and I hope that it would be great to study total station. So let us start. So what is a total station? Total station is a very useful instrument for every civil engineer. It is a combination of two instruments. First is an electromagnetic distance measurement instrument, and another one is an electronic theodolite. It is integrated with microprocessor, electronic data collector, and storage system. So there are plenty of things are there in one particular unit, and the combination of all these is called a total station. This instrument can be used to measure horizontal and vertical angle, as well as sloping distance of the object to the instrument. Total station is a compact instrument which weighs about 55 to 50 Newton, so a person can easily carry it on the field. What are its most merit is, this instrument is highly accurate, but it is costly also. Second one thing, that what type of data you can collect using total station. And microprocessor unit collect the data, and using that data, it processes the data for in several different formats, as whatever the data is collected by the instrument. Microprocessor can compute several things, as average of multiple angles measured, average of multiple distance measured, distance, horizontal distance between 2 points, elevation of object, all three coordinates of observed point, observed point. So all these six type of data can be computed. Means to say, it is not actually collected, but microprocessor compute these data from that type of data, which can be collected using EDM, theodolite, these two instruments. Here you can see that how a total station looks in picture, which is in your left side, where there you can see there is an eyepiece, handle, tripod, display is also there, and so many buttons are there. So this is your IP, means this is the back side of that, and on the right side you can see the front side of that total station instrument, where there is one type of lens you can see, which is of somewhere it is of blue color. Actually it is quite different. In actual time, it looks like a glass. It is just one picture which I have downloaded from Google Images, just to give a demonstration that how a total station looks. So in this particular slide, I must say, it is really a hack. It's a very complicated instrument, and whatever. Let us try to know that what are different bytes. At one, we have handle, so we know that handle is used for lift up that particular instrument to carry to ease. Second we have handle screwing screw. So in second we have handle screwing screw, means to say that connects the handle from the whole body. Remove handle if from the view. If you want to remove the handle, then we can do so. uh, Third one is data input output terminal. Remove handle to view, means to say we have here at point number 3, which might be at the back side for data input and output terminal. Might be possible there is any USB port or something like that would be there. Fourth one is instrument height mark. That mark is instrument height mark. That means that up to that line at 4 we take that height, and not above the handle, till not till of the handle. Fifth one is a battery cover, where there is battery because it contains a microprocessor, display, keyboard and all that, so it needs battery, it needs power to run. Sixth one is an operational panel. Using operational panel you can input specific values, or as this instrument is capable of showing the effect of temperature or any other weather in that, creating the effect. That's why, so using the keyboard you can input manual values. Seventh one, we have tripod clamp, in which so that where there you connect the tripod, and using all these 3 screws you level that instrument. And at the 8 we have a base plate, because a tripod is whenever we try to connect the tripod, then we place that base plate over the tripod, and then after we fix that using a screw, and then we label using these 3 screws. 9 is called labeling foot screws. These 3 screws are there, which you can say these are called foot screws. um, Next we have at number 10 circular label. Circular label is used for example, mm, that our instrument is labeled correctly or not. It is just we have one water bubble out there. At 11 we have circular level adjusting screw. Sorry, at 10 we have circular level adjusting screw, and at 11 we have circular level. So circular level adjusting screw will whenever we will use that screw, then it would change the overall orientation of our instrument. And we have to set that instrument according to in such a manner, so that at circular level, because there is one point there is one type of you can say circle, where there is a bubble. So you have to keep that bubble in the center of that circle in circular level. Okay, if you can keep that, then your instrument is quite labeled. 12 we have display. Display is used for just displaying all those type of data which that instrument is collecting using EDM, or using theodolite. Whenever it processes all those data, then it got certain values. So for displaying all those values, we have a display. At 14 we have tabular compass slot. At 14 we have tabular compass slot. um, 15 contains optimum optical plummet focusing ring. All these are quite of high level, so we don't need to study them in much a deeper manner. Overall, all these things you can understand more easily when you go on actually on site and understand that what is the use of each of these. By only listening, it is very hard to understand. So I'm not going to tell you that what is the actual use of all these type of 29. I have told you about 13, and these are good enough for the basics. Remaining all are not easy to explain in such a manner, like just by seeing. So let us look at what is next. So here is our next objective, that what are the different operations we can that instrument perform. So first one is distance measurement. So we know that distance measurement is done by electromagnetic distance measurement tool. Up to 2.8 to 4.2 kilometer it can measure the distance, and with accuracy of 5 to 10 mm per kilometer. Second one is angle measurement. So angle measurement process or operation is done using theodolite, and the accuracy varies to 2 to 6 seconds. Data processing, for doing data processing, there is an inbuilt processor given with that. It can also, that processor can create temperature effect and pressure effect with that. Fourth one, we have display. So display is just for showing the coordinates, horizontal, vertical, distance, angles, and all type of data which needs to be displayed or which needs to be delivered. And in electronic book operation, it is just for recording the data. For example, we are doing surveying and we need to record that data, and then after we can analyze the data using a computer or any electronic device. Then there is an option of creating an electronic book also given in that total station. And I would like to tell you that it can save data of about 2000 to 4000 points within the time. And then after you have to input that, and you can transfer that data into any computer, so that you can analyze and print the whole spreadsheet. So now let us look at what are the different advantages of instrument so-called tidal station. First one advantage is that field work is carried out very fastly. Why? Because we are using a machine or an instrument which is capable of doing all those type of work which a surveyor demands, or basically specifically collecting all those data within using only one instrument, because it can do all the works. So field work is very fast because we don't require a theodolite and a EDM separately. Okay. Second is accuracy of measurement is very high, because we have previously studied that this instrument can measure the distance at 2.4 to 4.2 kilometer, and with a very good accuracy of 6 to 10 mm per kilometer. So accuracy is very high. Manual errors are eliminated because all the data is processed by the processor, and computers don't do mistakes in processing if they are programmed correctly. So manual errors are almost eliminated up to 100%. Calculation of coordinate is fast and accurate because processors are there, so they can perform all those tedious calculations in very less time. Computers can be employed for map making and plotting contours, cross sections, contour intervals, and scales can be changed in no time, because you have all those coordinates, and using a computer, using a machine, you can easily you can easily perform map making objectives, plot the contours, cross sections, and if you want to do some changes or add it in that, then very easily you can do. So these are the various advantages of using a total station instrument. Thanks for watching, guys. I hope that you have enjoyed this video and understood the concept of total station. It is a very important instrument to know, and very interesting one also. Whenever you will go in field and work, then I hope that all this information will help you a lot. um, Thanks again. Get ready for more topics from civil engineering. Please do subscribe to my channel for being updated about new videos. See you soon. Have a great day. This is Shubham signing out.